So already looking, the rhythm looks pretty regular, but let's
Can play it again.
stop it at the end.
No.
Oh, that's what you want, right?
Yeah.
Okay. Okay. So, looking at the rhythm, I'm gonna start here.
Start where there's normal ones.
Normal, okay.
Measure the normal ones first. Does that? Okay. Okay. So what did you find?
I would actually say it's regularly irregular because it's regular on the normal R to R's, but then when we see these like abnormalities, it's inconsistent.
And when do those occur?
Well, here we have 6 R's and then one of these, and
but does it occur? 3. You said it's irregular, so does that mean it occurs before it should occur? The QRS, or
so when these occur, I don't see a P wave before.
Okay, but when do they occur? So maybe try this. Measure it from the Q's. So pick a Q to Q first. That is normal.
From here?
No, the normal ones.
Here to here?
Yeah. Okay, so then march those out. Okay, so they come at the same time, at the time where they should. Okay, and then what about that one?
So it occurs too early.
Too early. Okay.
Because this is the Q right here, right?
Okay, so if it's too early, that's the key word.
So
early.
It's premature.
Very good. So we got a premature beat.
Okay.
Okay, and we already know with the rhythm, you said it's regularly irregular. Okay, good. So we got a premature beat.
Okay.
Now we got to find out what kind of premature beat.
Right.
Right. So continue through all your analysis.
Okay, so I'm looking at if the P waves are normal. So I have a P wave here. P waves are present, so it's smooth, equal on both sides. And let me just double check.
Except, of course, for those times. Where you have those
okay, so they're consistent. I have one P wave for every QRS, except at these abnormalities. The PR interval is normal. So it's not prolonged, so we could eliminate AV block. I'm looking at the QRS and they're narrow. So that tells me that it's not a ventricular problem. Except at these points.
Okay, what's wrong with those?
So actually, they're too wide. So that keeps in the ventricular issues then.
Okay. What kind of ventricular issue? When did we say this occurs?
Premature. Okay. So it's looking like a PVC.
Yeah.
Okay. And can I stop there?
Yeah.
Okay. So it's a PVC.
But what's the underlying rhythm? If there weren't any PVCs, what is the underlying rhythm?
The underlying rhythm would be regular.
Not regular. What is it called?
Oh, regularly.
The name of the rhythm, not the rhythm, but the name of the rhythm. The name of the
like tachycardia.
Of the arrhythmia or dysrhythmia.
Regularly irregular.
No, the whole name of the EKG. What is the EKG called? Like the criteria. if the PVCs weren't there, what is the underlying name of the...
Oh, normal sinus
there
rhythm.
you go. Yeah.
I see.
So we call that the rhythm. I know it's confusing.
Okay.
But so this is a NSR with
PVCs.
what kind?
With premature.
Yeah. What we know it's PVC, but which kind? Based on shape.
Based on
I'm pushing you because I know you. I taught you that earlier.
Based on shape. Unifocal.
Very good. What does that mean?
Meaning that there's one.
One what? What does that mean in the heart? What does that mean?
Oh, there's only one place that there's the misfires.
That's right. Very
not
good.
multiple locations.
Very good. So this is an NSR with unifocal PVCs.
Okay.
Good job.
Thank you.
All right. That wasn't too hard, was it? That's one of the easiest to capture. Like you see it and go, oh, there's a PVC, right? Even in a telly. Okay, Annie.
So the telesitters, they're like pros at EKGs.
Yes. I used to teach those. It's a 3-day class, and they get certified. Yeah, we got a lot hired at Harbor UCLA because they recognize our class before. Because that's all they do is just look at.
Is that a monitor tech?
Yeah, EKG tech, yes. Okay, hold on 1 sec. Let me just make sure. This one I don't think I wrote on your list, Jessica, but we'll address it now.
Okay.
Okay. Oh, wait a minute. Sorry. Didn't mean to do that. Hold on. Sorry. That's wrong. Okay.
Oof.
That is not good. 12 lead. It's not showing. Don't rely on the 12 lead for this one because for some reason it's not showing you the right one. Exit again. Oh. Okay. So try the EKG, the 12 lead again. And we'll keep playing it until see if it actually shows anything here. Play it. Not seeing it here. Okay, so far. And this is the problem with even with PVCs because they don't occur regularly. You can do an EKG and not capture them. So for stuff like that, usually they'll need a holder, which is they wear the EKG for about 48 hours, 48 to 72 hours. Okay, that's not showing us anything good. So go ahead and X that out. Sorry, you're gonna have to go through the tally. So, yeah. So based on what Jessica had earlier, right? You know that those are what? The ones that were abnormal.
Ventricular Tachycardia.
What is it called? PVC.
Oh, the PVCs.
But what's wrong with these ones here?
Multifocal.
Well, do they all look different? Look at your list again. So on PVCs, you can categorize based on their shapes, right? If they're all the same shape, they're unifocal, meaning they're only coming from one irritable area in the heart.
They're the same shape.
If they're different shapes, that means that they're multifocal, right? But you also can categorize PVCs based on the frequency of their occurrence, or the, how many occurs at a time.
So it might be more of a run.
So what is how many is that occurring?
1, 2, 3, 4, 5.
Okay. So what is that called then?
A PVC run.
Yeah, so that's a PVC run. Okay. So you can say, what is the underlying rhythm?
Normal sinus.
So this is NSR with VTAC runs. What's the danger in a VTAC run?
The heart is, or the ventricles are contracting prematurely, like multiple times.
Okay. And then what could that lead to?
VFib.
Nope, not yet.
Ventricular tachycardia.
It could lead to a full-on VTAC,
VTAC.
right? Because it's a VTAC run. It occurs, so basically the heart is beating normally, and then all of a sudden it goes boom, 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 boom. And then it's normal again, right? And then boom, 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 boom. And normal again.
And it's not relaxing at all.
It's not relaxing in those times, so then it could convert to a full VTAC, right? Okay, that doesn't count, Ami. I'm gonna give you another one. Okay, here we go. Yeah, that's not cooperating for some reason. So X that out. You're just gonna have to look at the telly.
Okay.
And there's your telly.
Oh wow.
Tell me what you see. So if we were to go through the steps,
It looks like a.
do you see what's the
Okay.
rhythm?
It's irregular.
It's irregular, very irregular, yeah?
Very irregular.
Can you even count the rate?
No.
No. There's no rate. Right?
Mm-mm.
So therefore, can you see any P's or Q or S's?
No P's.
There's
no
nothing.
Q's.
Okay, how could you describe this rhythm? What is a term, a good keyword that you might use to describe this rhythm? It's very wet.
Other than tacky.
We can't call it tacky. It's very wet.
Quick.
What's wrong with it?
Inconsistent.
Inconsistent. What is another word that might be a good word to use? Start.
Indistinguishable.
Possibly.
You said irregular.
Well, yeah, it's more than irregular, right? So this is a disorganized rhythm, okay? Disorganized rhythm. So when you hear that keyword disorganized rhythm, right? You want to associate that with a fibrillation. There's two kinds of fibrillation, right? One with narrow looking QRSs, and this one
Is
has
wide.
no nice looking QRSs, right? The one with narrow looking QRSs but with disorganized P waves or undistinguishable P waves, that is called a what?
AFib.
A fib. Here, you can't even tell what's what,
Yeah.
right?
like a
There's no
VFib.
good narrow looking QRSs, so therefore this is a
VFib.
VFib. It's a disorganized rhythm, right? It's just fibrillating, nothing's going on there. What do we do?
Defibrillate.
Defibrillate. Good. What about this one? Still you, still you.
Oh. That looks like VFib.
Say again.
Ventricular flutter.
What do you, let's go through the steps.
Okay.
Now look at your 12 lead and see if this shows us a good rhythm. Yeah.
It's good.
So yeah, that first one doesn't count. Okay, that I think that first one just shows up just to tell you what would have been normal height.
Mm-hmm.
That's what that is for. Okay. What do we see there?
I see a quivering.
Quivering.
Yeah.
Quivering. Okay. What do you not see that worries you?
There's no QRS.
Aha. There's no
Cool.
narrow looking
There's
QRS,
no
right?
narrow.
Okay, so what is it?
So it's ventricular flutter. No, ventricular
Ventricular
fibrillation.
fibrillation. How is this different from the other one?
It's a fine.
This is a
This is
fine
fine.
VFib. Fine VFib. Because the electricity is, the amplitude is lesser, right? So if you have a patient who's coding, if they start with a coarse VFib, which is the one before, right?
Mm-hmm.
As they continue to lose electricity in their heart, it becomes finer and finer and finer and finer until
Yeah, the
there's no
flat
more
line.
electricity. Now it's asystole. Okay?
Okay.
Okay, X that out. Maybe a couple more. Let's see. Let's make a good one. Let's do this one. Oh wait. I'm fine. It's gonna say whenever we go with this patient, this the patient died. Let me put a healthy patient first. Because this one might die. Reset. Okay, put that back. This might throw you off a bit, but that's okay. It's gonna be a teaching moment if ever.
All right.
Okay. So analyze. You can pull your EKG if you want.
Yeah.
Let's see if it actually shows what I want to.
That looks like it does.
It's not
No?
as definitive. Hold on. Play it. Okay, yeah, okay.
Okay.
I'm happier with that.
All right. Do our steps.
You can pause it.
Okay. Is there irregular rhythm? Let's see. There appears to be a regular rhythm.
Okay, regular rhythm. Okay, good.
All right, and now we're checking for our rate.
Mhm.
So locating our R's. Okay, so it's a little bit of a slight range. I'm counting 5 boxes, 5 small boxes in between, sometimes 4.
Where are you counting?
So I started from here. Example, this is our R.
Uh-huh.
1.
Where's the next QRS complex after that one?
Right here.
Nope.
That's a P, or
Ah,
that's a P.
T.
That's a T. That's a T. Okay, so this is our P, Q.
So there's 3 positive inflections, right? Your P, your R, and your T.
Right.
And they always go in that order unless there is a problem.
Okay, so this is my P. This
That's
is
your P,
my
that's your
R.
and that's your T.
That's my T. So do we have a inverted ST segment here? No.
Do we?
No, sorry. This is
So don't jump into conclusions. So first, you know we have a regular rhythm. That's good.
right.
Now we're looking at the rate. So now you identified your R's. So then do your R to R.
Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8.
So
No.
5, 10.
Oh, okay. 5, 10, 15, 20.
No,
I'm sorry.
the big squares.
Big squares. 5, 10,
Yeah.
15.
Do you hit 15?
5, 10,
Okay.
11, 12.
Okay.
Okay.
I love how you just carry a calculator with you.
Clinical purposes. 125.
Okay.
So we have
So we have a what rate?
a tachy.
Okay, we have a tachy rate. Okay, with a regular rhythm so far, right?
Yes.
Okay, so we don't know what kind of tachy this is or if there's any other issues going on.
Correct. All right.
Okay.
Looking for the presence of a P wave.
Mm-hmm.
And there is.
Mm-hmm. And are they normal looking P waves?
Yes, there appears
Okay.
to be. They're between two squares on each. Oh, 1 square on each side of the
Okay.
grid marks.
Okay, so they're normal looking P waves
Mhm.
and there's 1 P for every QRS since you
Yes.
marched them out already?
Yes.
Okay, good. And then next. So we don't seem to have an atrial issue?
No.
Okay,
Then we're going to look at a PR segment.
okay. PR interval.
PR interval. Excuse me. PR interval.
The PR segment is from the end of the P to the beginning of the QRS. That's the segment. From the beginning of the P to the beginning of the QRS is the interval.
Okay. Beginning of P. All right. It is. What is the terminology?
It's not.
It's not prolonged.
Okay, so therefore there is no.
No no AV block.
Very good.
All right, now we're looking for an ST segment. See, we're looking.
Not yet.
Not yet.
So
Okay.
you were into PR.
Our QRS complex.
Good. Okay.
It's narrow, but it's not tall.
Doesn't matter.
Does it matter? Okay, so they're tall and narrow then.
So all you want to know is they're narrow.
They're narrow. Okay. They're narrow, and approximately each QRS complex at baseline has one small box.
Okay.
So we have no ventricular
Correct.
problems.
So far that we know of.
Okay, now we can go to our ST segment,
Yeah.
and we have, okay, so it's QRS. We have a inversion.
Where?
Right here. There's QRS. So there's inversion right here.
That's an S.
That's an S.
So there's two negative waves.
Oh, yes.
Q
This is,
and then S.
okay. Okay.
So it's like positive, negative, positive, negative, positive, right?
Okay.
P positive, Q negative, R positive, S negative, T positive.
Okay.
That's the pattern.
Okay, so this is.
So it's normal for it to be negative.
Okay, it's a little widened, but
That's not a thing.
that's not a thing. Okay,
So only the QRS
Okay.
width is what's important.
Okay.
So ST segment is just looking at the ST. Is it elevated, baseline, or inverted?
It's elevated.
It's elevated.
Yes, right here. So.
How elevated? It seems to be on an incline.
On
Is
an
what
incline,
I'm seeing,
okay.
Right?
Yes. About maybe 1.5 small boxes.
Okay.
One full, and then like about half of another.
Okay. Okay. And then what else do you see?
And then we're leading to a elevated T wave.
Tall.
Tall T wave. So we're
How
looking.
tall? In relation to the R.
It's taller than the R.
It's taller than the R.
Yes.
Okay. And what are your assumptions with regard to a tall T wave?
So we have a myocardial infarction,
Or
a case of hyperkalemia.
okay, what's the difference between the two? Chime in.
Diffused or local.
Okay, good. Now you need a 12 lead for that, right? What does diffused mean?
Diffused means that it's consistently throughout the whole strip. So we know that.
The whole 12 lead.
Oh,
Strip is just 3 lead.
Okay, yeah. So then that tells us that it's hyperkalemia.
Okay, can
to
you
do with
point
the
out on
potassium.
this one which one it is? Do you see, so diffuse means, do you see tall T waves in all the leads?
Okay.
Or in most of the leads?
And most of the leads.
Of the 12 lead, not just in the 12, not just in lead 2. Because right now you're
okay.
just in lead 2. So lead 1, lead 2, lead 3.
Not in lead.
Okay,
lead
that's
3.
fine. That's fine. So lead 1, lead 2.
Lead 1 and lead 2.
Okay, what about your precordial?
Precordial.
That's your V1 through V6. Are they tall there as well? Yeah. Okay, so therefore, is it diffused or localized? Is diffused. So is it possibly an MI or is it hyperkalemia?
Hyperkalemia.
Okay, and of course we'll validate that with the blood draw, right? Okay. So far we have a hyperkalemic patient, right?
Yes.
And then of course if it was, if you're in doubt, you obviously would assess the patient, right? If it was hyperkalemia, they're not necessarily going to have any chest pain. If it was an infarction, they will have chest pain or some kind of discomfort, right? Okay. So far, what do we know about this rhythm?
It's regular.
So yeah, what do we call the rhythm? And then
Sinus normal rhythm.
okay, so it's an NSR. Is it
Normal
NSR? Normal sinus.
Normal sinus
Is
rhythm.
it normal?
No, excuse me. It's not normal.
What is it? I mean, is it a normal sinus or is it something sinus?
It's a tachy.
So it's a sinus tachy.
Sinus tachy
With yeah, you can say that.
With diffuse
T wave.
with diffuse-
Possibly from what?
from hyperkalemia.
Okay, good. Now, I'm gonna kick it up a notch.
Okay.
I want you to look at the precordial leads and tell me what else you might see that is different. Precordial. Where's precordial?
We're looking at
Yeah.
V1, V2,
Yeah.
V3,
Uh-huh.
okay,
And
and V4.
up to V6 is
Up to-
precordial.
okay, up
all
to
of that.
V6.
All the V's is precordial. Okay, tell
Okay.
me something that you see that is different.
Okay.
Oh.
Teaching, you should know.
Okay. So
So that's actually AVF that you're looking at. So look to the right of it. So you see the letter V1, and then to
Yes.
the right is the rhythm that's assigned to it.
okay, so right here,
Uh-huh.
the zone. Okay.
Yeah. So V1. What do you see there that might be different?
That's a
So again,
P.
look at your
Okay, right.
3 positive
So
waves.
have my P. It's right there.
Okay.
P. There's my R. Okay, and my T is on an inversion.
Okay, it seems like they're all inverted. Move on to the next one.
Okay,
Next lead.
next lead. Okay, right here, right?
What do you see there?
Inversions as well.
Where?
My T wave right here. P, that's my R. This is normal here, correct?
Does it look normal to you? No? What's
No,
wrong with it?
because the if you split it in half, the P wave, it's not the same on both sides. It looks more pointed to the right
Right.
a little bit.
Which one are you guys looking at?
I'm looking at this.
V2.
No, that there?
Uh-huh.
Okay, I'm gonna give it to you. That's the QRS complex. That's part of the QRS complex. So what you're seeing is an R and an R1. There's 2 R waves.
Oh,
Okay? So an R and then an R1,
okay.
otherwise known as your rabbit ears. So rabbit ears, when you hear that word, you associate it with what, Jessica?
Right bundle branch.
Block, right? So that's how our BBB looks like in V2,
Right bundle.
right?
right
And it's
block.
in V2, which is the right side,
Okay.
right?
Correct.
So what happens is when they get, so this is conduction issue,
Yes.
right? When it gets to the bundle branches and it splits into the right and the left bundle branch, in the right bundle branch, there's a problem, there's a blockage. And so what the electricity does is it flows, it hits the blockage, it backs up, and then it finds another route, which is what creates the R and the R prime, or R and R1,
Okay.
rabbit ears. Okay. There's not necessarily a problem. You will just monitor the patient. It could be benign, unless in this patient we have another issue, which is the hyperkalemia. So then, therefore, we're gonna need to, take care of this patient, right? But so this is an RBBB patient with tall T waves, so probably hyperkalemia.
Okay.
That's a little bit advanced, but I just wanted to point out the right bundle branch block just in case you see it.
Okay.
And that's
Thank
how
you.
that looks. All right.
Okay.
Okie dokie. One more, or a couple more. Unless your brains are fried. Are your brains fried? Emmy's not talking. She's just smiling.
I'm taking it in.
Okay, are you next, honey? Oh, Jessica?
Yeah, me.
Okay, go ahead, X that it out. There you go.
Okay. Okay.
Mm. Okay.
So,
Mm-hmm.
so far, as far as the rhythm,
Mm-hmm.
it looks regular just looking at it. Or, actually, no. Let me check.
This, your pictures will help with.
I also keep looking so I can connect
Mm-hmm.
this here
Yeah.
to what I have here.
Okay. So our rhythm is regular.
Okay.
As far as the rate, I'm like going cross-eyed. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4.
4 small squares?
Yeah, so it's about 4 small squares
Okay.
consistently.
So 1,500 divided by 4 squares. 4 small squares.
375.
375.
So we know we're tacky.
Uh-huh.
And I noticed that the amplitude of
Uh-huh.
the waves are very different.
Good.
So I can't really distinguish a P wave or
Uh-huh.
QRS
Uh-huh.
or T or anything really.
Okay. Okay. What are you seeing though? What waves do you know for sure you're seeing?
I want to say they're P waves.
No?
No? Oh, R's. Like you
QRS
said?
complexes. Those
Okay.
are QRS complexes.
Okay.
What's wrong with them?
They're inconsistent.
Okay, what else? What about the width?
One.
They're, let's see. Well, this one's like 1.5.
From the base.
2, oh. 1, 2, 3, 4.
Okay.
1, 2, 3, 4.
Okay.
1, 2, 3, 4.
Yeah.
Okay.
So we know we have a what rate?
Rate.
Yeah.
Tacky.
Okay, so we have a tachy.
Mm-hmm.
What kind of tachy?
Ventricular tachycardia.
So we have a VTach.
Okay.
Okay.
And
So that it's a VTach, but
Uh-huh.
so you would have been already correct with that. Now you mentioned something about amplitude, so we're gonna add another term
okay.
that I haven't talked to you guys about yet. So if you step back a little bit, tell me what pattern you see from lead 2.
Lead to, it's like, I don't know if this is the right,
Amplitude. What
Mhm.
happens?
it like is a little bit bigger, then it goes
Uh-huh.
smaller, then
Okay.
it goes bigger, then it
Okay,
goes smaller.
there's a pattern, right?
So it's like intermittent almost.
Yeah. Okay.
Mm-hmm.
So you might even say that you can associate it with party streamers.
Oh.
Party streamer pattern, right?
Okay.
It goes big, then it goes small, kind of like those party streamers,
Mhm.
they twist, right?
Mhm.
So you want to associate that word with what we're going to categorize this at, right?
Okay.
Technically speaking, we call this a polymorphic VTach. Polymorphic because there's different sizes,
Okay.
right?
Mm-hmm.
It's big amplitude and small amplitude, big and small, polymorphic,
Mhm.
okay? Polymorphic VTach. Look back at the telly for me.
Mhm.
So that would have been correct.
Okay.
But there's another name. Anybody know what the other name is for a polymorphic VTach? You should know this, Ami. It's a language you speak. It's in French. It's in French. The name of it is in French. What is it?
Is it with an A?
No.
No? The C?
How many French rhythms do you know? I only know one French rhythm. No? Okay. Give up? This is Torsades du Pont.
Oh, that's not the point.
Oh, we learned that with electrolytes.
Yes.
That happens
That's
with
the one I did not print.
hypo something.
Hypo what?
Calcemia?
It could, but usually our first thought is hypomag.
Okay.
Yeah.
Okay?
Yeah.
Hypomagnesemia. So that's one potential cause is
The
hypomagnesemia.
one I did not print.
Or associate the party streamer because people who party drugs. Okay, drug toxicity is another potential cause of
Okay.
Torsades. Okay, this is a deadly rhythm. So this is a VTAC without pulse. Okay, that's why you see 0 there.
Yeah.
So you see it's tachycardic. The conduction is fast.
Yeah.
It's extremely fast, right? 300s, right? QRSs are wide. So by definition, it's a VTAC, and there's no pulse. So by ACLS algorithm, what are we doing? We're
Defibrillating.
defibrillating.
I see.
Okay, and then when you go to the H's and T's, which are the possible causes of a code, then you know that for Torsades, you're looking at the hypos. So first one is hypomagnesemia, hypocalcemia, hypokalemia, and then again drug toxicity. Okay, so those are the things that you guys would associate with that, and it's classic, pattern, right? So you see the party streamer. Okay.
Oh, nice.
Let's see if there's any more.